I'm a structural geologist, so I'm interested in how the rocks deform. So the sample that I decided to take in this expedition are two different types of research. So I'm interested in looking at the deformation along the fault rocks. So I collected sample as much intact as possible in order to make thin section and study under the microscope the type of deformation that the fault rocks develop. So I'm interested in the evolution of this. And the other type of sample that I'm taking are to perform shearing experiments. So there's a machine in Rome, back in Italy, where I live, that can perform it can mimic the deformation during an earthquake or at different other velocities. So the idea is to look at the evolution of the deformation while a rock is speed at different speed velocity. That's it.
Actually, what we do, or what I do specifically, is we do rock friction testing. We test how strong it is, and not only how strong it is, but how it behaves when the rock is perturbed in some way, right? So if you're for example, a fault zone deforms very, very slowly, but depending on what's happening in the earth, they can jump or be pushed to move faster. So what we do is we test this condition exactly. We shear the faults very slowly, as slow as we can. We can actually simulate 5 centimeters a year, which is actually how fast the plates are moving in the Hikarangi trench, right? So we simulate that condition and we push the faults faster, and we see how the fault responds. Does it get weaker? Does it get stronger? Does it make earthquakes? Does it make slow earthquakes? And that's basically what we want to find out.
So I'm taking a whole sample to do some experiment, deformation experiment in my lab in Texas. So I'm taking a sample at the different depths, and I'm going to do the deformation experiment at the different pressure and temperature conditions that can simulate the in situ conditions.